So your final result should have 3, right? Yeah. So your final result should have only 3 significant figures. Right? So if you do the multiplication, the result will be, right? So the result, the final result, you can only keep 3 significant figures, right? 5, 6, 2. Agree? Okay. Okay, C. C, now, so the first number, how many significant figures you have? 3, yeah. Second one? 2, right? So your result can only have 2, right? Yeah. So if you do the calculation, you will get 0.00239, right? And you can only keep 2 significant figures, right? So it's not 0.0004. Okay. Okay, then it comes the addition and the subtraction, right? The rules are different, right? So addition or subtraction, you need to follow the number of decimal places, right? You need to follow the minimum number of decimal places. So for this case, 33, how many decimal places you have? 0, right? Second one? 1, right? So the result can only have 0 decimal places. Right? These are the 2 rules, right? Actually, if you look at our, for my part, right? There are just a few rules you need to follow, right? For this one, basically, if it's addition and subtraction, right? You need to follow the minimum number of decimal places, right? If it's multiplication and division, you need to follow the minimum number of significant figures. Right? It's just the 2 rules. Okay, so 33 plus 435, right? So the final result will be 465.5. Huh? Oh, sorry, 468. Yeah. And the final result you can only have 0 decimal places. Right? So how many? Okay. Right. Okay. E. So E is division, right? So division, we need to follow the same rule as multiplication. So the first number has how many significant figures? 3, yeah. The second one? 3, yeah. So your final result? 3, yeah. Okay. So if you do a division, you will get this number, right? 0.18479. Yeah, something like that. So you can only keep 3 significant figures, right? So it will be 0.185. Okay. So the last one, now it's a subtraction, right? So the first, if it's a subtraction, you need to look at what? Decimal places. So the first number has how many? 2. First, second? 1. Right? So final result, you can only have 1. Right? Yeah, don't forget this one. Yeah, so your result will be 71.4. Right? Okay, question 4. The scientific notation, right? So give the following number in scientific notation to 4 significant figures, right? So the first one will be 5.654 times 10 to the power of minus what? 3. So here is you have 4 significant figures. So the B, it will be what? It will be what? 1.250, right? Times 10 to the power. 3 or 2? 2. C will be 9.384, right? Times 10 to the power. 4 significant figures. 3.4. 0, 0. Yeah. You need 2 more zeros. Times 10 to the power 6. And the last one will be 1.001, right? 4 significant figures times 10 to the power minus 7. Right. So question 5 is very similar as this one. So you only need to keep 2 significant figures. Okay, so let's look at the some practical examples. Right. So in an exam, right, usually you will see the question like this one. Right? They seldom ask you like this one. Yeah? So this type of question, right, are embedded in a question. They will ask you, okay, you calculate the two multiplication, what is your result? Right? Yeah. But the exam question usually is some practical questions. Right? Then you need to apply the rules, yeah, in the result. Right? So, but these are the basics. Right? Okay. So question 6, yeah, you need to read the question. Yeah. So the important part is you need to understand what the question asks you. Right? So the first is the mass of the glass beaker, right? Was measured. So the mass is 45.64 grams. So when a liquid was added to the beaker, right? So now the mass is 92.5. Right? So give the mass of the liquid in the beaker to the appropriate number of significant figures. So what is this one? Yeah, it's just minus, right? So you know the total mass, right? Then you know the mass of the beaker, right? So it will be total mass minus 45.64, right? So again, so this is what? Subtraction, right? Subtraction, we need to look at what? The decimal places. Right? So the first number you have 1 decimal places, right? Second, 2. So the result, only 1, right? Yeah. So what's the result? So if you do a direct subtraction, you will get this one, yeah? So you can only keep a report as 46.9 grams. For the unit. So, question 7. So, in a heat transfer experiment, the amount of heat is transferred to silver at the melting point, causing a mass of M of the silver to melt. The relation between M and Q is given by its multiplication. Q equals M times L. L represents the heat of fusion. So given heat is L is this much and Q is this much, so calculate the mass of the silver. And also and then report express your answer in a scientific notation to the product number. Okay. So this is what is a multiplication question, right? So you know L, you know Q, right? So M equals Q over L, right? Q over L, right? So Q is 455.0, right? L is 88. Okay, so now this is division, right? So we need to look at what? The significant figures, right? So this one has how many? 3 or 4? 3, right? So this one has 3 significant figures. This one? 2, right? So your final result can only have 2, right? what is your final number? If I give you this one, right? Yeah. What is your final number? So you can only have two single figures, right? So it will be 5.2 times 5.2 times 10 to the power minus 2. Agree? Okay. Okay, so as part of the experiment, right, the student was required to find the density of a small sphere. So the student notebook entry is shown below, right? Okay, so what are the mistakes you can correct? So you need to find out the density of rho, right? So you need to use the mass divided by the volume. Right? Mass divided by the volume is the density. So the volume of the sphere is 4/3 pi r cubed, right? For the sphere. Right. So if the mass of the sphere is 0.44 gram, right? So the diameter of the sphere is 4.76. Okay, see. So your R is this one, yeah? So if you want to calculate the volume, right? So what should the volume, what should be the volume numbers, right? So R, you have how many single figures? You have 3, right? So volume, you can only have 3, but because this is an intermediate result, right? So you need to have one more significant figures. So this one you need to keep 4. Right? So it will be 451.8. Yeah. The correct way to report this number. Because any intermediate result you need to have, because otherwise if you run down the error, right? The error will try to propagate to the final. Right? So this one you need to keep as a 451.8. Okay. And also there's a mistake here, right? If I don't know which one, right? If it's a diameter, right? This one you need to divide by 2, right? Right. Yeah. So this one you need to divide by 2. But anyway, yeah. You can calculate the number yourself. Huh? Okay. Then the density of the sphere basically is a mass divided by the volume, right? So this is division, right? Division, then you need to look at the even figures, right? The first number you have how many? 2, right? So this one just now you keep 4, right? So the final result you how many? Yeah, you can only have 2 significant figures, right? Yeah. So you can only keep up to here, right? All right. Okay. Are you any questions so far? Any questions so far? So let me summarize again, right? Huh? Let me summarize again. For the first part, right? We talk about how to report the numbers, right? Basically, we have 2 rules, right? One is if it's addition and subtraction, right? You need to look at the number of decimal places. Right? So the result is to follow the minimum number of decimal places. Right? That's one, right? And rule number 2 is if it's multiplication and division, right? You need to look at the number of significant figures, right? Okay. And the result need to follow the minimum number of significant figures. Okay. Okay. So question 9. So question 9 now is is the uncertainties. How do we report the uncertainties? So for the uncertainties, again, we have two rules, right? So the first rule is the number of significant figures for the uncertainties, you can only have one. Right? That's rule number one. Secondly, the best estimate results need to have the same order of the magnitude as the uncertainties. So what does it mean? So again, there are two rules here. Okay, what does it mean here? So the uncertainties, you can only have one significant figure, right? So uncertainties is here, right? So how do we report this uncertainty? It will be 0.03, huh? Okay. One significant figure. Secondly, the first number here, which is the best estimate result of the velocity, right, need to have the same order of magnitude as the uncertainties. What does it mean? So your uncertainty is not here, right? Actually, is you have two decimal places, right? So what is the order of magnitude for your uncertainties? Actually, it's 10 to the power of minus 2, right? Okay. Yeah. So your best estimate result need to have the same order of magnitude, right? So you can only report up to here, right? These two numbers have the same order of magnitude, right? Okay, how about B? So X equals, so if you look at uncertainties for this case, which is correct, right? Uncertainties is 2, right? So you only have one significant figure, which is correct, right? Then how do you report the best estimate result of your but if you report as 3, right? But it's 3 times 10 to the power 4, right? So your actual number is 30000, right? So this one has a different order of magnitude, right? So this one actually, if you report this way, right, the order of magnitude is actually the number is here. Right? So what should you report? You should report as a 3, 1, 2, 3, 4. Do you agree? So right? So part B actually this number is already correct. So if you want to write it as a scientific notation, also can. So what does it mean? It's a order of magnitude, right? So if it's 20, right? What is the order of magnitude? Your order of magnitude is actually is great. It's 10 to the power of 1. Yeah, it's a second number here. Right? So, okay, let me ask you this question. If my uncertainty is this one here, okay? If my uncertainty is 20, right? How should I report this number? Huh? It will be 3, 1, 2, 3, 0. Okay. Then let me ask you one more. If it's a 200, right? Then it will be 3, 1, 2, 0. So these two will have the same order of magnitude. Okay. Okay, C. Yeah, C will be the mass, right? So if first you look at the uncertainties, right? Is it correct? The uncertainties you can only have one significant figure, right? So which is correct for this case. Right? So which is 3, up to which position? Here you have -7, right? So where is your -9? Will be, this is -8, right? This is -9, right? So you can only up to here. So it will be 5.68, right? 10 to the power -7. Right? Okay, again T. Okay, T. Anyone can give me the number? What is the uncertainties you need to report here for this case? So it will be 0.04, right? So okay. And how about the best estimate exam? 5.03, right? So yeah. So 5.03 plus -0.04. Yeah. So these two numbers will have the same order of magnitude. Yeah. This part I saw you are quite a bit confused. Think about it. What is your? Let me show. I'm not sure whether in the notes has the. Yeah, so again, if you look at your notes, right, you have two rules here, right? So the uncertainties should always be rounded to one significant figure, right? So that's rule number 1. Of course, that's special case, right? If your first, the number is 1, right? So you need to keep 2, but that's the special case, right? Okay, and the rule number 2 is the answers, or just now I say is the best estimate, right? So the answers should be given to the same order of magnitude, right, as uncertainties, right? So if you look at this example, right, if your uncertainties of the velocity is 30, right, so basically your uncertainties is, what is your order of magnitude for the uncertainties? They'll be in here, right? Actually it's 10 to the power 1. Yeah. And then if your answers for V, right, is this one, right? How should you report the number? So you should report as 6050. Yeah, 6050. So if you report as 6051, then they will have a different order of magnitude, because if it's 6051, right, so your order of magnitude actually is 10 over 0. Yeah. So you have to report as a 6050. So then it will have the same order of magnitude as 30. Okay. So how about the E? Anyone tell me what's the answer for E?
1.5 plus minus
1.5 plus minus 1. Yeah. So if you follow strictly the rules, right? The uncertainties here now is correct, plus minus 1, right? So which only have one significant figure, right? So which is correct. Then, how about the best estimate for this case? If you strictly follow the rule, right? What is the number you should report? 2. Yeah, it's 2, right? Yeah, 2 plus minus 1. Right? But of course, I mean, for this case, you can argue, right? So because the original value is 1.4 something, you run it up to 2, right? So the error, it becomes quite big, right? So you can always say, okay, I want to keep one more significant figure for this case. So you want to replace 1.5 plus minus 1, right? So that's all right. Okay. Okay, so then if you follow the loop, it will be 2 plus minus 1. Okay. Okay, so how about the F? So how about F for this case? So F, the uncertainties, now you have only one single figure, right, which is correct. But now you have so many zeros, right? What is that? 4, 9, right? So it will be 7 times 10 to the power minus 9. Right? So this basically is your order of magnitude. Right? Yeah. So your L need to have the same order of magnitude. So we will be. So this one is 2, 4, 6. Yeah, it will be 5, 6, 3 times 10 to the power 9. I also want. Right. Okay, how about the G? G, for the uncertainties, what is the number you should report? You should report as what? As 40, yeah? Okay, 40. And how about the best estimate? Yeah? So, what is the best estimate? So now, what is the order of magnitude here? It's 10 of 1, right? So what is your best estimate? You should report your answer. So your answer actually now is a 3267. 3267. Yeah, so it will be 3270, right? Okay. So how about H? H, so the uncertainty is here. Yeah, because it's the first number is 1, right? Yeah. So you need to have 2 significant figures for this case, right? Because it's 1, right? The first number. So what is your best estimate for the X? It will be 3.3. Yeah. All right. Okay. Okay, so rewrite the following measurements, right? So A, you need to write it as a fractional uncertainties. Yeah? So fractional uncertainties is what? Is basically is what? Is the uncertainties in percentage, right? Yeah? You need to use your absolute uncertainty divided by your best estimate result. Right? So for this case, it will be 2 divided by 55. Right? So this one gives you what is number here? So 3 by something, 3 by something percent. Right? So again, you need to only keep one significant figure, so it will be 4%. Right? It will be 4%. So your result will be 55 plus minus 4%. Okay, so again here, the second one, what is the percentage uncertainties? So you need to use what? 2 divided by 20 times 10 to the power 4, right? 2 divided by 20 times 10 to the power, sorry, 10 to the power 4. Right? So this one, what do you have? Actually, it's a 10 to the power minus 5, right? Right. So this one will be what? 0.001%. 10 to the power minus 3%, yeah, which, let's say. Okay, C. C you need to report as absolute uncertainties, right? So the fractional uncertainties is 2%, right? It's 2%. So what is your uncertainties in E? It will be 4.58 times 2%. Yeah. So what do you have here? So this one gives you how much? 0.0916 something like that. Right? So again, uncertainties you need to keep only one significant figure, which is 0.09. Right? Yeah. So your final result, uncertainties is 0.09, yeah, plus minus 0.09, and the best estimate will be need to have the same order of magnitude, yeah, for this case. Yeah. So what do you have here? 4.58, right? 4.58. All right. Do you have any questions for this one? Okay, if not, let's look at the question 11. Okay, question 11 basically, okay, you need to estimate the acceleration of a car. So the student measures two velocities, right? One is the initial velocity, one is the final velocity. So, and calculate the difference delta V, right? So the two results, the measurement results, VI and VS, right, have the uncertainties of 1%, right? So this is your fractional uncertainties, which is 1%. Right? So calculate the absolute uncertainties for all the four measurements and find out what is the V, delta V. Find out what is the delta V. Okay, you have the VI, right? You have the VF. This is file number 1, and this is file number 2. Okay, so your the best estimate is 14.0, right? So because it's 1%, right? Fractional uncertainties, right? So what do you have here? It will be 0.14, correct? Yeah. The absolute uncertainties will be 0.14, right? Yeah. So for this case, you need to report two significant figures, right? Because starting with 1, right? Yeah, you keep 2. All right. So, and then for second one, again is 18.0 plus minus 0.18. Okay. And here it will be 19.0 plus 19. And the last one will be 19.6 plus minus. So for this case, it will be what? 0.02. Okay. Then how about the delta V? Huh? 0. Oh, sorry, 0.2. 0.2. Okay, so how about the delta V? So delta V basically, this is a subtraction, right? Subtraction, you need to subtract the best estimate value first, right? Which is 4, right? And you know, for addition and subtraction, the uncertainties, right, in the final result will be what? Will be the summation of the absolute uncertainties, right? Yeah. Again, you see, we always have two rules, right? The first one, right, for the numbers, we say the addition and subtraction, we need to follow the minimum number of decimal places, right? The rule number 2 is for multiplication and division, we need to follow the minimum number of significant figures, right? That's for the number reporting. Second one, for the uncertainties, right? We say the rule number 1 is the uncertainties we need to have only one significant figures. That's rule number 1, right? Rule number 2 is the best estimate result need to have the same order of magnitude as the uncertainties, right? That's rule number 2. Okay. And here, for the propagation of the uncertainties, right? The rule number 1 is if it's addition and subtraction, right? The uncertainties in the final result is the summation of your individual absolute uncertainties, right? Yeah. Still remember. For addition and subtraction, right? It's the summation of the absolute uncertainties. Okay, rule number 2 is if it's multiplication and division, right? The final result, what is the uncertainty in your final result? You need to sum your fractional uncertainties, right? So basically, the multiplication and division, you need to look at the fractional uncertainties, and addition and subtraction, you need to look at the absolute uncertainties, right? So again, there are two rules here. So if you are clear about this one, and that's about it for the reporting part. Okay. Always two rules. Of course, I mean for this course, this part is the basic part, right? The more important part will be the later. If we talk about the probability and all those error propagation is the important part. Okay. In the exam, in the lecture, right? We have the examples. You know, on the we have the function of one variable. We have the function of two variables, right? And how the error is going to propagate, and you need to do a differentiation, all those things. Okay. Anyway. Okay, for this one, right? Because delta V is Vi minus Vf, right? So, what is the uncertainty for this case? Huh? What is the uncertainty for this case? Huh? What is the uncertainties for this case? Okay, so actually, to make it correct, because now we have we keep two significant figures here, right? So this one we need to have same order of magnitude as this one, right? So you should have one more zero, right? Agree? Yeah. So they have the same order of magnitude, right? Because this one is accurate up to 10 to the power minus 2, right? So you should have two zeros, right, to represent your 10 to the power minus 2, right? So this case is all right. Okay, so what is the uncertainties in delta V? So because this is what? It's a subtraction, right? So what is your uncertainties in your result? Your uncertainty need to be what? Need to be the summation of these two, right? Okay? So it will be 0.32, right? 0.32, but because uncertainties, we say we only need to keep one significant figure, right? So 0.3, right? Then your result here, you report as a 4.0, right? To have the same order of magnitude. Right? And how about this one? So what is the uncertainties here? Anyone tell me? What is the uncertainties in the result? Yeah? Anyone tell me what is the uncertainties in the final result? So the uncertainty should be 0.39, right? You need to sum these two, right? It will be 0.39, right? Then you report as 0.4, right? No, 0.4. Then the best estimate will be this one minus this one, right? It will be minus 0.6, right? Okay. Then, all right, are we done part A? Yes, we are done, right? So B, you need to calculate the percentage uncertainties, right? And comment on the final answer. So again, we need to report as a percentage, right? Then what is the fractional uncertainties here? So if you want to calculate the fractional uncertainties, right? Then this one you need to use 0.32 divided by this one, yeah? 0.32 divided by this one, you have what, 8%, right? Yeah. And here, if you use 0.39 divided by this one, it will give you how much? It will give you 60 something percent, 65% maybe. Then if you want to report the percentage, yeah, 66. Yeah. Then you need to report as 70%. So have only one single figure. Okay, so you can see this result, right, has very big uncertainties, right, in terms of the percentage uncertainties. And do you still remember what is the quadrature uncertainties? Quadrature. Huh? You need to look at your notes, right? Yeah. So you can report your final answer here, right? Just now we say the simple way is we have the uncertainties in this number is 0.14. This number is 0.18, right? Because it's subtraction, we just simply add these two together, right? Yeah. And in the lecture, we also discussed you can use quadrature sum, right? So which will be 0.14 squared plus 0.18 squared and do a square root. Yeah, this is also correct. This is also correct. So you look, you calculate this one and twice. And both are correct answers. Okay, let's look at the question 13. Chart? No chart. Okay, question 13. So the calculator gives you an answer of this one, right? You know the x has a fractional uncertainty of 2%. Okay, question 13. So the question asks you x is 6.1234 plus minus 2%. How do you report this uncertainty? Right? So if you look at what is your absolute uncertainties here? So you need to use this one times percent, right? Correct. So this one gives you 0.12 something. And this one times this one gives you 0.12 something. So So because the starting is 1, right? So you need to keep 2 significant figures. So it's 0.12, right? Okay. So what is your best estimate result for here? Huh? What is the number here? You should report. Huh? Huh? It'll be, so the best estimate result need to have the same model of magnitude as this one, right? It'll be, huh? 6.121. Okay? Yeah. Agree? Okay, so B and C are the same, right? I agree with you. Okay, question 14. So the two students measures the length of the rock, right? And report their results. Report their results as one is 135 plus minus 3, and the other is 137 plus minus 3, right? Is the discrepancy significant? Yeah? So question 14. So this one you can actually have multiple ways of explain this one. Yeah? Okay. Okay. So one way you look at it is the first student actually is 135 plus minus 3, right? So the range will be from your best estimate is 135, right? The minimum will be 132, right? Maximum will be 138, right? Great. The second one will be the best best estimate is what? 137, right? The maximum is 140, right? Minimum is 134, right? Yeah. So if you look at these two measurements, right? They have this range, which is from 134 to 138, which is overlapping, right? So actually, which are all right. And you can look at the other way is if you do a difference between these two, right? L1 minus L2, right? L1 minus L2, right? Then what do you have? L1 minus L2. The best estimate value you use 135 minus 137, which is minus 2, right? And what's the uncertainties? Uncertainty in L1 is plus minus 3, right? This one plus minus 3. So what is your uncertainties of this subtraction result? Huh? Uncertainties in L1 is 3. Uncertainties in L2 is 3. Right? What is the uncertainties of the result, final result? 6, right? Good. So it's plus minus 6. Yeah. So you can see actually the difference of this one actually is smaller than your uncertainties, which is not significant. Right? Yeah, you can explain in both ways. Agree? Okay. Okay, so question 15. Question 15. A student measures the density of a liquid 5 times and get a result of this one. So what would you suggest the best estimate for the density? What is the best estimate of the density? So So what is the best estimate of the density? What is the best estimate? So how do you find the best estimate of these measurements? Huh? What do you need to do? You do an average, yeah, get an average result of these 5 measurements. So you will get 1.9. 1.9, which is your average. Then the minimum and the maximum for this one, right? Minimum is 1.8, right? Maximum is 2.0, right? So your uncertainty will be 0.1, right? Okay? 1.9 plus minus 0.1, right? So this one will covers all the values, right? Your maximum values. Agree? Then the student is told the correct value is 1.85, right? So is the discrepancy significant for this case? It's not, right? Because if your best estimate is 1.85, right? So actually it's within this range, right? It's all right. Okay. So question 6, right? Question 6 is an angular momentum, right? So an experiment is performed to check the conservation of angular momentum. Right? This one is, I'm not sure whether you still remember where is the angular momentum, but that's okay. Yeah? So the measurement tells you what is the initial angular momentum, where is the final angular momentum, right? So you need to show the result, which is initial momentum minus the final momentum, right? So what does it mean, the conservation of angular momentum? So conservation of angular momentum basically tells you the initial momentum and the final momentum need to be the same. That's the, I'm not sure whether you still remember. You learned from your physics, right? If you have two balls collision, right? If the collision is the elastic collision, right? The initial momentum and the final momentum need to be the same, right? Okay. Okay, so the first one you have 3.0 plus minus 0.3, 2.7 plus minus 0.6, right? So the last column will be L minus L prime. So what will be the result here? What will be the result? L minus L prime will be minus 0.3 plus minus minus what? 0.9, right? 0.9. Because the uncertainties you need to add. Right? The second one will be 7.4 plus minus 0.5 and 8.0 plus minus 1.0, right? So what do you have here? Minus 0.6 plus minus 1.5. So this one 40.3 plus minus 1.0, right? 60.5 plus minus again 1.0, right? So what is the uncertainties here? 2.0, right? Or 2, right? It is 2. Right? And this one will be minus 2.2, right? Minus 2. last one will be, the next one is 25 plus minus 2, right? 24 plus minus 2, right? So the result will be 1 plus minus 4. Yeah. And 32 plus minus 2. This is 31 plus minus 2, right? So what will be your result? It will be 1 plus minus 4. So the last one will be 37 plus minus 2, right? It is 41 plus minus 2. So the result will be minus 4 plus minus 4. So what you need to check is, in theory, right, the result here needs to be 0, right, because of the conservation of angular momentum. Right? So basically you need to check whether the 0 falls within this range. Right? So 0, is it 0 in this range? Yes, right? No. 0, 0, 0, 0, right? So they are all correct. Right? Okay. So, question 7. Okay. So the next 4, 5 questions, right, are the plotting, right? You need to do a proper plotting. So as I told you in the lecture, right? So this type of question definitely will appear in exams. Right? In the exam, you are required to draw a graph, right? If you given certain data. Right? This type of question definitely every year there's one question on this one. Okay, so basically you need to do a proper graph, right? Okay, let me show you one example. Right? Okay, so if you look at the question 7, right? So basically you need to plot a graph of the projector here cannot show the okay. So basically this kind of graph, right? You will get you need to use in the exam, right? So for now, actually, you should get some of the graph like this, right, to do practice. If you in the exam, it's the first time you do the graph, definitely you will get some mistakes somewhere. Right? So you need to get some of this graph paper to do a practice before the exam. Right? So basically, this is the graph, right? So what you need to do is okay. So first you need to determine what is your x and what is your y axis, right? So for my case here, my x-axis will be your initial angular momentum, which is L, right? And for L, you need to put you need to put the unit on it. So it's kg. Okay, and for the y-axis, will be your. So I cannot see here. Okay, yeah. It will be your L prime, right? Again, you have the unit of kg. Okay. And next thing you need to look at is what is the scale, right? What is the range for x, right? So if you look at the data, the data is from the minimum is 3, right? The maximum is 37, right? So what you need to choose is you can choose from 0 to 40, right? So you can choose 0, 5, 10, 15, 20, 25, 30, 35, and 40. You need to choose a proper range. Right? And also for the graph paper, right? You need to fully use of your graph paper. Right? If you are given one page, right? Don't draw only in the center. Right? The rest are empty. Right? That's not a graph paper. Right? Okay, and if you look at the final momentum, right? What is your range? What is that? So the range here again is the minimum is 2.7, right? The maximum is 41, right? So what you need to do is again you need to choose 5 to 40, right? 15, 20, 25, 30, okay, 35 up to 40. Okay. Then how do we do the plotting? So for the first number, right? For the first number, the initial momentum you have 3 plus minus 0.3, right? So the minimum will be what? 3 is here, right? 3 is here, right? 3 is here. And the final momentum will be 2.7, right? So what is your best estimate value here? Will be some here, right? That's your best estimate value. But because you have uncertainties, right, you need to draw the error bar. Right? So 3 plus minus 3. So x will be this one. And the final momentum is 2.7 plus minus 6, right? So it will be 2.1 to 3.3. Yeah. Is it correct? Yeah, 2, 3. 2.7 it should be here. That's why 2.7 it should be here. So yeah, so we go this one. And the final momentum will be 2.1 to 3.3, right? 2.1 to 3.3. Somewhere here. Okay, so this will be your first point, right? So you have the uncertainty in x and you have uncertainty in y, right? So you need to draw this error bar. Okay, the second one, 7.4. Okay, so you need to find out where is the 7.4, right? 7 point somewhere here, right? So 8 will be here. Okay, and 7.4 you have plus minus 0.5, right? Sorry, 0.5 uncertainties. So it will be from this one to here. Okay, and 8.0 plus minus 1, then it will be from 9 to. So 8 is here. Sorry, again it's wrong. Yeah. So 8 will be 9 to 7, right? Here. Okay. So again, you need to remove this one if it's wrong. Okay, this is the second point. The third point will be 14.3 plus minus 1. 14.3 is where? 14.3 is somewhere here, right? And 16.5 will be somewhere here. This one, right? 16.5. And the x is plus minus 1.0, right? So it will be this one to here, right? 16.5 will be this one up to here. Okay, that's your third point. Okay, the fourth point is 25 plus minus 2, right? 25 is here, right? 25 and y is 24, so the best estimate point is this one. Right? And the x is 25 plus minus 2. 25, then this is 23 to 27. Right? And your final momentum will be 22 to here. Okay, then you continue the plotting. Alright? So a few things, right? I have to you need to be careful, right? First, what is your x-axis and where's your y-axis? Yeah, because the question in the exam, I don't know. Yeah, every year are different. Right? So first, you need to be clear where's your x and where's your y. You need to put the unit on the axis, and also you need to choose the proper scale, right, for your x and y. Right? Let's say for this case, right, your data is from 0 to 40, right? So your scale here, you need to start from 0 to 40. And let's say in the exam, let's say you have the data is from 20 to 25, let's say. From 20 to 25. Then your scale may not start from 0, right? You can always start from 20 and 25. Okay? If you start from 0, then your data will all be here, right? The rest are empty. Okay? So again, for the y-axis, you need to also choose the proper scale, right? All right. So for this part, actually, you have to do some practice. Otherwise, you will miss out some of the details. Okay, so after you let's say now you have 6 points, right? After you draw the 6 points, then you can use your ruler, right, to draw a best fit line, right? Yeah. Let's say you have a ruler here, you draw a line here, right? Okay. Okay. In theory, yeah. In theory, this line should pass through what? Should pass through the origin, yeah? Okay. In theory. Yeah. But if your measurement has some issues, then it won't pass through the origin. Yeah, because the conservation of momentum tells you the initial momentum and final momentum need to be same. So by right, this line should pass through origin. And do you have any questions? Yeah? Okay. If not, then we look at the question 18. This one you need to practice. I leave it to you. Okay, so the question 18 is you have the mass of the car, which is big M, right, and trailer, which is small m. Right? The result are in a standard form, which is best estimate plus minus the uncertainties, right? So what will be the best estimate of the total mass of the system? Yeah? So the best estimate of the total mass will be what? It's a big M plus small m, right? And also by considering the maximum and minimum probable values of total mass. And so this one I think you can do, right? Yeah. So yeah, sorry, I haven't switched the so question 18. Okay, basically this one actually is from the lecture notes, right? We have the mass for the car, right? This is my car, right? Which is best estimate plus minus delta m, right? And the maximum value? Max value. Maximum value of n plus n, right? So it will be, what is the maximum value? It will be when both values are maximum, right? Correct? Yeah. So it will be n dash plus small n dash, right? And plus delta n plus delta small n. Yeah. So what is the minimum value? Mean value of the n plus n. So this one will be when both values are minimum, right? So it will be n dash plus small n dash. This is plus minus n. It will be minus. Yeah. So from here, actually you can see, right, your best estimate will be this one, and uncertainty will be plus minus. No? Right. Okay. This is actually consistent from what we discussed earlier. Right? For the addition, right, the uncertainty basically is the summation of individual uncertainties. Okay. So question 19. Question 19. So from the ideal gas law, I'm not sure whether you still remember what is the ideal gas law. Ideal gas law basically is PV and RT. So P is the pressure, right? V is the volume, right? N is the number of mole, right, for the gas. Right? R is the constant. T is the temperature in Kelvin. Right? So that's the ideal gas law. Right? So the question tells you if the volume is constant, right? This is constant, right? And this is constant also, right? And for certain gases, not, it's also a constant. Right? So that means your pressure, right, need to be proportional to the temperature, right? It's proportional. So the check the test result, right? So you have the measurement data here, right? Which is in temperature and pressure, right? So plot these results in a graph, right? To decide whether they confirm the proportional relationship, right? So basically what you need to do is, again, you need to find out what is the, you need to get a graph paper, right? You need to plot the temperature and the pressure, right? So temperature is in Kelvin and pressure is in ATM, right? So you need to do a proper graph, right? So for this case, the temperature is 150 and achieve 300, right? So you can plot the temperature in this range, right? 150, 200, 250, 100. That's the temperature. Right? What is the pressure? Pressure will be from 0.36 to 1.04, right? So you can do the range will be 1.2, let's say. So this is 0.6, and this is 0.9. Yeah, just give you one example. Right? So you can plot this one in a graph paper, right? to check whether your this graph, right, shows a linear relationship, right? Okay. And what is question 20, right? So question 20 is if a stone is thrown vertically, right, with the speed, right? So it has, it follows this equation. So which is V squared equals 2gh. So g is the gravitation constant, right? Which is 9.88 something, right? So basically, if you look at this one, right? If you plot the graph V squared versus h, right? You should get a straight line. Okay. So part A, basically you need to make a plot, right? Yeah. Including the vertical and horizontal bar, error bar. Right? And yeah. So it will be V squared and h. H will be in meter. This one will be in meter square. So the data are given to you. Right? Okay. So you need to plot in the graph, and the slope, right? The gradient of the line, right, gives you what? Gives you this 2g value. Right? So you need to check whether this value is close to what you expect, right? 2g, what is the 2g? 2 times g, you should expect was 19.6, right?
Yeah, 19.6.
So your gradient of your plot, right? It should be close to 19.6. Yeah. So again, this one you need to do, right? Even I show it to you, there's no actually there's no much point. Right? This kind of problem you need to do it yourself, right? Because in the exam, right, it will be different question, right? But the principle is the same, right? You are given a set of data, right? You need to do a plot, and you need to find out what's gradient. Yeah? This is kind of very standard question you have. But every year the data will be different, the equation will be different. That's the only thing. Yeah. So you have to prepare for this kind of question. Okay, so if not, then we can finish today here, and then you can, if you have any questions, you can ask me. I'll be here until 11.